Hello guys, in this first lesson, we introduce the topics we are going to study in this term. Now, these topics are designed and they are based on the CAPS documents, the topics that we have to follow from first term to second term to third term up to the fourth term. And the design is in such a way that for each term, the topics are divided into weeks, or the topics are divided into subsections that are then taught during the week. For example, as you can see here, we have the first week, week 1, then week 2, week 3, week 4, week 5, week 6, like that, up to week 10. So first term has got 10 weeks, and the topics in first term, they are indicated here. The first topic being what? Exponents and surds. And in exponents and surds, the things that we have to study in week 1 and week 2 includes simplifying expressions, okay? Simplifying expressions, then later solving what? Solving equations using the laws of exponents for rational exponents. Then also addition, subtraction, multiplication, and division of simple surds to include simple equations involving surds. That is what is supposed to be what? Covered in the first and the second week of term 1. Then in the third week, we begin a new topic of what? Of equations and inequalities. Now, equations and inequalities cover 3 weeks, week 3, week 4, week 5. And under equations and inequalities, we study completing the square, solving quadratic equations by factorization and using the formula, then also solving quadratic inequalities in one unknown, then later interpreting the solutions. The other thing is equations in 2 unknowns, one of which is linear and the other being quadratic. Then also determining the nature of roots. Now, these are the things to be covered under equations and inequalities, to be covered over a period of 3 weeks, starting with week 3 to week 4 to week 5. Then after that, in week 6, week 7, and week 8, the topic to be covered is Euclidean geometry. Now, Euclidean geometry will be covered with specifications indicated here below. The line drawn from the center of a circle perpendicular to the chord bisect the what? The chord. Then the perpendicular bisector of a chord passes through the center. Then the next thing we'll be looking at the angle subtended by an arc at the center of a circle is double the size, okay? Then angles subtended by a chord of a circle on the same side of the chord are equal. So these listings are some of the things that we will be studying, or are the things that we will be studying in what? Euclidean geometry, which is supposed to be from week 6 to week 7, then to week 8. Under Euclidean geometry, those are the things we will be studying. Then following the next week, which is week 9 to week 10, the topic will then be trigonometry. Now in trigonometry, we will be looking at deriving and using the identities or trigonometrical identities. The first one being tan of theta equals to sine divided by cos theta not equal to k, okay? Plus these other definitions here. Then the second thing is deriving and using reduction formula to simplify expressions such as these ones indicated here below. Then the third thing to be covered in trigonometry will be determining, okay, for which values of a variable an identity holds. So these are the topics to be covered in first term over a period of 10 weeks. Again, there are in total 4 topics. The first topic being exponent and surds, the second one being equations and inequalities, then the third one being what? Euclidean geometry, and the fourth one being trigonometry. That is for the topics to be covered. Now we will move just a little bit further and look at the contents of this first topic, which is exponents and surds. Now for this one specific lesson, the first thing we want to look at here in exponents and surd will be the laws of exponents right here. So the laws of exponents, sorry, there we go. Okay, so the laws of exponents, before we go to surds, okay? Before we go to surds, the laws of exponents starts with the definition of exponent itself. What does it mean when someone talks of exponent? What do we refer to? Well, the word exponent, also known as an index or a power, indicates the number of times, okay, a variable or some number is multiplying itself, okay? The number of times in the multiplication, a given number is multiplying itself. For example, when you look at a, in this case, a raised to power n, or a with exponent n, this means a is multiplying itself n number of times. That is the definition. Now, in this case, a is known as the base, n is known as the exponent, or what? The index. So again, exponent or power or index indicates the number of times a given number or a given variable multiplies itself. Now, if we write that, in simple terms, let me just get it written right away here, the definition. Now, what the definition here means is if we have a number like a with a power or an exponent, okay, with a power or an exponent, which is, say, 2. This by definition means a is multiplying itself 2 number of times. So a is multiplying itself for the first time. So that will give us a. Then when a multiplies itself 2 times, we will be having a and a. In other words, a is appearing in the multiplication 2 times. Now, if we look at another definition, rather, if we look at another example where a is raised to some other number, okay, let's say 3. Now, by definition, this means a is multiplying itself 3 times. In other words, we're having a, okay, times a, then times a. That is what it means by definition. Now, notice that in the example that we'll be looking at a little bit later, the multiplication sign can be changed and we can use a dot to represent multiplication. Meaning if we have like a raised to power 5, which in ordinary terms we can write as a times a, okay, a for the first time, a for the second time, a for the third time, a for the fourth time, and a for the 5th time. Now notice that this one can also be written as, that is a raised to power 5 can be written as a dot, okay, we use what is called dot product. A dot A dot A dot A dot A 5 times. So that is what we mean by the definition of an exponent. Now, in this case, 5 is called the exponent, also known as index or a power, and A is known as the base, the way it's been defined here. Now, notice that in all these cases, A must be a real number and N is a natural number, meaning N can be 1, N can be 2, N can be 3, and stuff like that. That is the definition. Now, for the rules, here are the rules. So in this lesson, we are just reading the rules. Then in the next lesson, we will begin to apply the rules. Now, the first rule here, also known as the product rule, states that if a number is multiplied by itself, so if a number A raised to power N is multiplied by a number A raised to power N, rather M, pardon, if a number A raised to power M is multiplied by another number A raised to power N, then we can simplify this as A raised to power M plus N. Now notice that the reverse is also true. This then means, should it happen at one time that we have A raised to power M, okay? Should it happen at one time that we have A raised to power M plus N, we can also write them as A raised to power M, okay? A raised to power M times A raised to power N, okay? This is what we have. Now, it's very important to understand that this law, which is known as the product law or the product rule, it works either way, forward and backward. So you can have it in the forward direction, or you can also find an expression given as this in the right-hand side and you take it to the left-hand side. This is true. The second rule is known as the quotient rule. Now, the quotient rule means if a number A, or if a variable A with exponent M is divided by A with exponent N, this can then be simplified as A with exponent M minus N. The reverse is also true. What this then means is that if we have at some point A with exponent M minus N with exponent M minus N, then we can write this as, we can then write this as A with exponent M, okay, divided by A with exponent N, okay, divided by, we can use this sign of division, there isn't any problem with that, A with exponent what? With exponent N. This is known as the what? The quotient rule. Now the other rule, which is the third rule, is given here, okay, known as the power rule, sometimes known as the exponent rule of products. Meaning if you have at any point an external exponent for an item inside the bracket, then you can split the exponent onto each of the items as A raised to power N times B raised to power N. Now notice that the reverse is true. What this means is that if you have A with exponent n, okay, if you have a with exponent n and another number or variable b with exponent n, you can write this in a bracket as a and b, okay, with an external exponent being what? With an external exponent being n. Now, we move on to the what? Onto the power, what is also known as the power law of quotients, which is like the fourth law here. Now, the fourth law here means if you are having two items dividing themselves inside the bracket, and there is one item outside the bracket, you can then simplify it as a raised to power n divided by a, rather b raised to power n. The reverse is also true in the sense that if you have a raised to power n, okay, a raised to power n divided by b raised to power n, okay, divided by b also raised to power n, then you can write this 2 as what? You can write this 2 in a bracket with the n being the exponent outside the bracket, and inside the bracket, what will you be having? You will be having a divided by what? Divided by b. Yes. Then the next law is the last law in this case for this method. We have a with the m and another exponent n outside. Okay, so for this expression, we can simplify it as indicated, and the reverse is also true, meaning if you have a with exponent mn, okay, with exponent mn, you can write this as a, rather in a bracket, you can write this, the exponent can be outside as n, then inside the bracket you have what? You have a with exponent m. Okay, you have a with exponent m. It's indicated there. Now, these ones are known as the laws of exponents. Okay, they're known as the laws of exponents. Now, there is one more thing I would like to add here, the identity property, which we will also be looking at. It will be appearing in what? In some of the calculations that we have. The identity property is that if you have a number like a with an exponent of 1, you can actually simplify this as a. The other thing here is, if you have a number or a variable like a with an exponent of 0, this then simplifies to what? To 1. Now notice that the reverse is also true. We can write 1 as a raised to power 0, or we can write a as a raised to power 1. Okay, now these ones form the basic foundation for laws of exponents. Now, the other thing you don't want to miss is the case of radicals or the case of fractional powers. But that comes with these other sets of laws we have right here. Now, for this section, if r raised to power n can be written as a, then to find r, to make r the subject, we find the nth root of A written as indicated here. Now, the other thing is, if A is now written as the nth root, rather, if A has got an exponent of 1 over n, we can simplify this as the nth root of A. Even in this case, the reverse is true. The nth root of A can be written as A with exponent 1 over n. The other thing is called the negative exponent or the negative power. Now, for this element of negative power, if we have A raised to power negative 1 over n, we can then write this as A with power of negative 1, then we have 1 over n outside the bracket. We can still simplify this because we had already seen that 1 over n means the nth root. A raised to power negative 1 is the same as 1 over A. And the last part we don't want to miss is this one here. A raised to power m over n can be simplified as A raised to power m with 1 over n outside the bracket. And this is known as the nth root of A raised to power m. In the cases above, A is greater than 0, R is also greater than 0. M and N are what? M and N are real numbers or are integers. N cannot be 0. Now, by definition, the whole of this expression here is called a radical, with A being the radicand, the radical sign is the square root sign, and N being the degree. So this is where our first lesson stops. In the second lesson, we will now start to apply these formulas here, the definition, the rules of exponent, the identities, then the rules of exponents applied to rational or fractional numbers. This is where we stop. Let's meet for the next lesson.